So this is just a little summary of the presentation I gave yesterday at the Home School Expo at the Palm Beach Atlantic University in West Palm Beach, organized by Parents Educating Children organization in Palm Beach County. And it's a talk on mathematical reasoning in your home education program. So first of all, I'd like to talk a little bit about why study mathematics. And I'd like to suggest, especially for today, these three priorities, these three goals. First, as a way to practice careful thinking. Second, as a way to develop a sense of beauty in the coherence of mathematical structure. And third, as a way to develop a sense of truth and a sense of objective reality, or to practice relating to the truth and experiencing objective reality. And of course, there are many goals, there are many possible goals or reasons to study mathematics, but I'm focusing on these because I think these are especially relevant and useful today, where if you imagine priorities or on a spectrum and maybe a pendulum swinging, we've swung very far, generally speaking, in a utilitarian view of mathematics and an efficiency-directed view of mathematics. And I think one of the consequences of that is often the experience from the student's perspective is that it's very mechanical and often even rote. And those characteristics are, I think, fundamentally alien to mathematics, which should be understood and should be appreciated as a great intellectual achievement with a lot of beauty to offer. So I'd like to go back a little bit, or go back to the beginning of the effort to understand the world that we live in carefully with the ancient Greeks. And in ancient Greece, in fact, that's where the term mathematics comes from. And mathematics has an interesting meaning in contrast to other subjects. It's fairly abstract. It comes from Greek and it means learning or studying or understanding or knowledge. So it really, you can see right in the name itself, this focus on making sense of the world that we live in, making sense of the reality that we live in. And I think it's worth noticing that the very first philosophers were also mathematicians. And I don't think that's mere accident. I think that the disposition of mind that mathematics helps to cultivate has that orientation, that curiosity to put human reason to the purpose for which it is intended, of understanding and making sense of the world that we live in. And that today, we're often, just by virtue of the scale of things and the way things are organized in society, there is a great focus on the utility and the economics of anything that we do, including something like mathematics. I think it's worthwhile to refocus on goals that exist in mathematics that are directed to something more human and intrinsic to mathematics, which is intrinsically a very beautiful subject. So I propose that our key priority in studying mathematics ought to be careful thinking, and this is a great place to practice careful thinking mathematics. So the idea behind this book, From Quantity to Number, to help homeschoolers in their math programs, was let me say threefold here. First of all, from the outset of studies, to enable students to see ideas foundational to more advanced studies in mathematics. Second, to prepare students right from the outset of their studies to understand the real number continuum and the need for irrational numbers. So we will be evolving the concept of number as a means to represent the quantity that we observe around us through our work in arithmetic and reflection on number as we go along. And in particular, to prepare for the idea of the finite infinite sum, which actually we can see, of course, in the for example, in the decimal expression of rational numbers that require an infinite decimal expansion. And there's a lot of insight to gain from looking carefully at that when we get to that point in our study of rational numbers, looking forward, looking towards filling the gaps of the rational numbers so that we can represent. We have a system of representing quantity in numbers that we can map onto the geometric representation, numbers as points on a line, which is an important goal for us. So from the outset of the studies, I want to make or would like to create this program is designed to help students develop an awareness of these questions that lead us into the study eventually of calculus, and because that's a very beautiful space, and it's worth for its beauty and power, I think to make it a priority to study. So from quantity to number is intended to help families kindle this careful thinking through discussions. It does introduce ideas that are foundational to more advanced ideas early, so that children, and this is, I think, very important, have the time to turn these ideas over in their minds for a while. So you look at a lot of programs, math programs, and they get started in arithmetic. I'm talking about, like, look at the whole span from K through 12. You start off with arithmetic early on, then there's sort of, I would say, kind of a cycling over in the middle years, and then the goal of most of these programs is to get kids to calculus. That's the structure, because calculus is so useful for many different things. But usually that happens towards the end of high school, and the approach to calculus is often fairly mechanical, and does not necessarily convey the beautiful ideas well in that underlie calculus. I would like to be clear, though, that in our approach, we put a huge effort into practicing, solving problems in mathematics. So I don't mean to diminish the importance of the practical, having a facility in the practical aspects of mathematics. But the important idea is that that facility certainly can be developed in a framework that features prominently the interesting ideas that can certainly from the outset be developed intuitively and give direction and not only direction, but I think can enrich the practical study, the practical work, can enrich it with a great purpose. Right? It was directed to the beauty of mathematics. And then the text is designed in a way that the topics are connected coherently based on their relationship. So we don't just throw together sort of a collection of different topics. And I think that that's important because one of the great sources of the beauty is the coherence of the mathematical structures and how everything does relate, and all the important ideas relate and fit together. And so I'd like to nurture a sense of that and awareness of that from early on. So how to study mathematics with this text and this is really especially for the homeschool context, but it's not necessarily limited. It's just this is to provide this approach for families interested in homeschool. Now, many families in homeschool have discovered and value the discussion-based approach in other subjects that they do. The reason I'm pausing is so I'd like to make a note on and I mentioned the Greeks, Thales, and of course there's also the early philosophers were also mathematicians. So I mentioned Thales, who's Aristotle refers to him as the first philosopher, and there is Pythagoras that many people know also for mathematics, also a philosopher. He reasoned his way first to the idea of the immortal soul, and in addition to his work in music theory and in geometry. And Plato had studied mathematics very carefully. In fact, I think the inscription at the front of the academy where that he founded and where he taught was, I think it was something like, "Let no one enter here who is not a mathematician," something to that effect. Just to re-emphasize the importance of mathematics for those who were really beginning carefully to think about the world, that is to reason their way to understanding the world. There's a key idea that the human reason was being put to this task of making sense of the world. And the first efforts of these philosophers were to observe and to try to understand in a reasoned way the material world, the physical world, right? So it's natural philosophy, so to speak. And of course, the reason I came back to that at this point here is because Socrates, especially, is famous for the method, the dialogue method, and that is a very effective way to teach. And many homeschool families use this method in teaching most of their subjects, often not mathematics. Often mathematics in homeschool is provided for with a box curriculum. And the point of this text is to enable families who are interested in pursuing a discussion-based approach also in their math program to be able to do that. And the book is, you can read it from cover to cover. So it's complete in its explanations, it has many examples, many exercises with solutions and illustrations and so on. But it's also intended as to be a source of ideas to help parents lead discussions on the math ideas that we develop. So it starts from beginning counting, so it's the first course in mathematics, works its way all through arithmetic and arithmetic through fractions. And I think that corresponds generally to what you would find in a conventional program in America through 5th grade at least, and some of the topics maybe even further. I think that so the idea is that the two pillars of this approach are discussions on one hand and assignments, and I'll talk about that on the other. Preferably discussions every day, and they don't have to be long discussions, but it's good to do them every day. Anything that you want to do, if you do it every day, that's a good way to build a lot of momentum. And if you decide, to do mathematics, which is a good thing to decide, make it a priority, focus on it, do it every day. In the beginning, it might just be a few minutes. Even with little children, 10 minutes a day can move to 20 and 30 minutes, depending on how much time you want to allocate every day. But discussions every day are important. All you need for this is all we use is just a blank notebook where students and parent teaching can write down, either do sketches or write down problems they're discussing and to solve those problems. It's like the chalkboard for homeschool. It's just a blank notebook that you can write on together. That's all you need. And this is also an important feature of the program. It's a very simple logistics, because the simpler the logistics for you, the more likely you are to do the mathematics every day, and that's what matters most. So if you're traveling, if you're going somewhere, either on a road trip or on an airplane, you should be able to find a way, a few minutes in that day, wherever you are, to do a math discussion and to keep building momentum in your math program. And also maybe even incorporating connecting what you're doing in mathematics with the other things you're doing in your life. That's one of the homeschool advantages. So discussions, daily discussions on interesting mathematical topics. I mean, and I think when I say that, you should be able to find interesting ways, hopefully through this text, as you're solving problems or exploring the ideas through different problems to solve, those I want to say simple prompts in the problems themselves are ways to lead the discussion, and the discussion keys off of where your students are, and parents are often in the best position, based on their familiarity with the language of the students, to know what a student understands or what a student needs to work on more. So daily discussions, that's one of the pillars. The other pillar for this program is assignments by specification. And what I mean by that is I don't give students worksheets with problems. I give them specifications directed to some purpose. But I want the students to have the opportunity to create their own questions. And of course, with this, you can tailor the specifications as broadly or as narrowly as you want in order to achieve your purpose in that moment. If, for example, you think this student needs a lot of work on this kind of exercise, you can be very specific in tailoring your questions. But if you want to give more latitude in a particular space for the student, then you can be broader in your specifications. So there's, I think, a lot of benefits to this. Two in particular. One, the first is that the student, by having to take the initiative of thinking up questions, this gives a perspective on the topic that I think helps the student learn better. When you have to think of questions in connection with a problem, it helps in the understanding. It's also good, of course, for the student to have the experience of thinking of questions, because that corresponds to what mathematicians do. You get a worksheet, they have to think up their questions. So that's what real life is. That's what everybody does, really. In most people in real life, right? You take the initiative of what you need to work on. So that's a good experience and a good disposition of mind to nurture early on, and you can do that in the assignments process by enabling the students to have this opportunity to make up their own questions. There are other advantages too. Let me talk a little bit about things that we don't do. I do not use computers in any way or any kind of technology like that. I do not think it's necessary, especially at the early age, and I think it's often counterproductive. A lot of times work on computers is directed to learning features and functionality of proprietary software, and much of that is likely to be obsolete within a short amount of time anyway. I think most of that is just distraction from what matters most, and what matters most is careful thinking based in interesting ideas. And you don't need any kind of technology for that, really. You need to be focused on the interesting ideas. Although the technology, that is a book, a notebook and a pencil, those are useful to help build the discussions, and also it's important to have a notebook and a pencil when you're reading a math book or when you're doing mathematics. I'll get to that in a second. So you don't need computers. You don't need any of that stuff. It doesn't. I think you you're not losing anything by not using computers, especially at this age, and you're gaining a lot because with computers are all kinds of distractions beyond the question of whether what is being studied or used on the computer is even necessary to your purpose. And I think that this is a problem today because there's a infatuation in our society with technology, and oftentimes it's a misplaced infatuation, because it's the skills that are being learned in connection with those technologies are not useful. The other thing that you don't really need to do more of is any kind of testing, although there is one test that I'll talk about subsequently. When you're developing a study through dialogue or discussion, the testing is implicit in every moment of your discussion, right? You're working through problems together, and in that way you're getting a sense of exactly what your student knows on the point that you are teaching, and if the student has difficulty with the problems you're working on, then you circle around it and try to find a new way to connect with the student so that you can illuminate what is the idea that needs to be understood better, and keep moving forward. So the testing is implicit in this method, in this process of studying and teaching, so that there's no need really for the separate testing, and so you don't have the additional stress and extra administrative work for that is part of the testing. The need for testing really is something that flows from if teaching a group, right? So school teachers have a much more challenging task because they have to manage groups. They have to be able to assess the understanding of the students in the group, and everyone's a little bit different. It's much harder in some sense than teaching one student, right? So that's the essence of the homeschool advantage, really. So you might as well take advantage of that benefit, that advantage in homeschooling, and do things differently, including in mathematics, because you're apt to be able to do things better that way. For families who might be thinking about that, or think, hey, this sounds kind of interesting, but it makes me a little bit nervous to step outside of the conventional approach so much, some reassurance. So in Florida, there's a test called the Post-Secondary Education Readiness Test, and it's administered in schools in 11th grade. And it's got 3 parts: reading, writing, and mathematics. So I looked at a text to help students prepare for this test, and it had 19 sections, topics for mathematics. And 9 of those sections were fully covered directly in this first volume, From Quantity to Number, Volume 1, so the first course. The others, many of them could be built out easily from that, but of course this is just the first course. We're just getting started here. So there's plenty of time. The point is that I think that if you are pursuing seriously your discussion-based math program, you subsequently were to decide that you want to re-enter a conventional program, you would be able to do that without difficulty. There's another reason to know about this test also, and all homeschoolers should keep this on their radar, this post-secondary education readiness test, because there's a great opportunity in Florida. In high school, and including homeschool students who are in high school, they're in the high school years, Florida allows what they call a dual enrollment, where high school students, including homeschool high school students, of course, can enroll in college level classes so for their 2-year program, right? But the great opportunity here is that so you can high school students can go through these 2-year programs. But when they go into a 4-year program, they can get credit for those 2 years. So then what that means is you can have students completing their 4-year program, they get in 2 years, right? So there's obviously a great savings in time and a great savings in tuition and all the rest. So that is an excellent opportunity for families to know about. The way that you get into it is by taking this post-secondary education readiness test, and you can take that test as soon as your students are comfortable taking it, and then you can do the dual enrollment program if that's something that interests your students. It's a good opportunity to know about. So I would like to talk a little bit about next steps. Working on Volume 2, and Volume 2 really is moving into this idea of developing the sense of the real number continuum, building on the foundations from Volume 1. Remember, Volume 1 starts from beginning counting, works through all of arithmetic and the arithmetic of fractions. In Volume 2, I begin by building on the work that we did in Volume 1 to build out the powers of 10, generalizing that, the power exponentiation relationship. So we study, first of all, exponentiation. Then from that relationship, from the exponentiation relationship, we study roots, and we also study logarithms. That's the first 3 chapters. Chapter 4 will focus on the idea of counting closer. That is really one of the themes running through the text is arithmetic as counting, right, in different ways, in all of the arithmetic operations, but often the first intuitive understanding in dealing with counting, dealing with numbers, is you're counting up and you're looking towards the infinite in some sense. And here we really turn our perspective in counting to counting in a way that's getting closer and closer. So an easy way to see this is to consider, for example, consider the rational number 1/3. And if you think of that number in its decimal expression, you have this infinite decimal expansion, 0.333 and so on forever. And what is that? It's an infinite sum, right? It's an infinite sum. You're saying, okay, I'm going to take 3/10. It's a counting of tenths, 3 of them, 300ths, 3,000ths, and so on forever. And that the value that is expressed by that decimal expansion is the value 1/3. It's a sum which has infinitely many terms. And of course, the neat thing there is that even though you've got infinitely many terms, the overall value is bounded. It's finite. And this is a very neat and important idea that from which you can extract lots of insight that's useful for calculus. But in any event, we take our time developing these ideas, including with concepts like the geometric series and so on, developed very carefully, incrementally, to give students more and more insight about the different kinds of numbers, the need to step from rational numbers as a representation of quantity into something more, to be able to capture also the quantities that are not expressible as rational numbers, for which we need this idea of irrational number, and thinking of number as process in order to be able to do that. After that, I think a student who does those those two volumes would be prepared to step into a pre-calculus class, a course, or even a text or a calculus text, depending. And originally that was what my plan was, because I think that calculus is very interesting, and that's plainly the goal of most math programs. We started playing around with geometry, tried different texts. One thing led to another, kept coming back to looking up Euclid, and so then just decided to study Euclid, make that our next study. And we have enjoyed this so much, working through the 13 books of Euclid, so Euclid's geometry, and there are so many benefits that flow from studying Euclid that I have been working on 2 texts to help families navigate through Euclid. Sometimes the language is a little bit arcane. It takes time to decipher. There are other things to connect with, the way we describe things in more modern language, but also just to help people who don't necessarily have the familiarity. But it's such a worthwhile text that we've spent our time in this, and so that's what we've been doing. I just want to signal a few resources. A website, of course, inletbooks.com, where we post the book and other things, resources for homeschool families. Also, the preface from Quantity Number Volume 1 has guidance on how to use the text, how to read the text, and on the program, if you had questions on that, and there's a mailing list. So those are other ways to connect. And if you're thinking about doing homeschool, or you're working through how to teach math in homeschool, feel free to reach out to us.